On Home Factory, we douse some flames
Then we take a relaxing swing.
and find some flatware that's a cut above.
But first, we check out some heavy metals.
It's a Home Factory fun fact. Did you know that cast iron pans have been used since the 4th century BC?
And did you know that you're a cookware nerd?
Oh, darn right I am. So we're headed to Lodge Manufacturing's 160,000 square foot facility in South Pittsburgh, Tennessee, home of the cast iron pan and this giant fancy pan statue thing.
And this is Scott Leakey, the Foundry Support Manager for Lodge. He also knows a lot of interesting facts about cast iron.
Something a lot of people don't know is you can actually get your daily allotment of iron intake from using cast iron cookware to cook with.
No way!
Grandma must have known best because that's all she cooked with.
And Grandma's secret weapon starts with, wait, there are pans in that pile of metal.
Yes, the iron is actually a combination of our returns, which are gating and scrap castings, purchased pig iron, and purchased scrap steel.
Pig iron? What's that?
Well, as any cast iron cookware aficionado knows, smelting iron ore with a high carbon fuel in a blast furnace results in a crude iron known as pig iron.
Yeah, you're a hoot at parties, aren't you?
Yes, I am. The pig iron and scrap metal is picked up by this huge industrial magnet.
But how much of each material goes in?
The mix of our cast iron is a little bit of a company secret.
So you're not going to tell us?
Correct. I'm not going to tell you.
Okay, fine. We'll just go ask James. He's the melt supervisor, and he'll definitely tell us.
And that's asking me for $1 million for me.
Ah, fine. Well, when the 9,000 kilogram secret blend of metals is ready, it is violently shaken.
Oh, it's very violent. This vibrating conveyor takes the metal to the furnaces. Lodge has two 10-ton furnaces, which melt the metal at 1,500 degrees Celsius.
It takes 40 minutes for the furnaces to melt all that metal into hot liquid iron.
And so while we're waiting, we should probably figure out what's going to happen with all that metal when it's melted.
Lodge uses sand molds to create their cast iron pans. Sand is the only material that can stand up to the heat of the molten iron without melting.
This machine compresses moist sand into a mold shape that forms the exact contours of the skillet.
Sand molding is just like building a sand castle.
Okay, but there's sandcastles that have hot, molten metal spewed into them like some kind of automated hell beast dragon.
Okay, so who's nerdy now?
Or I think it's still you. But look at how awesome this is.
Well, you're right. I mean, that's really cool. Let's go talk to the man on the scene. This is Jackie, and he's ready for action.
Sometimes you gotta strike when the iron's hot.
Big fan of smelting jokes, I see.
You can say I'm a metalhead.
Okay, I'll be making any puns from here on out, thank you.
The molten metal is allowed to harden and cool in its molds.
In a year's time, we can make in excess of 3 to 3.5 million castings.
The molds are then dropped onto a conveyor, which breaks the sand apart, releasing the pan. The vibrating conveyor shakes the sand off the pan.
The cookware then goes into a giant rotating drum, also called a didion. A blend of iron pieces in the didion smooths some of the rougher patches on the cast iron.
Each pan is then inspected, and a factory worker grinds off any sharp edges.
And next it's time for these pans to go see Bruce in the cleaning department.
It's bath time.
The pans go into a soap and water bath, but there's something special about these bubbles.
What's that?
Made out of steel, hardened steel.
The steel balls scour off the rough patches on the steel pan.
The smoothed cast iron pans are then hung on hooks.
These don't look like the cast iron pans my grandmother used to use. They're gray and not black. Care to explain, Mark?
Yes? No? Please?
A lot of people make the mistake and call cast iron cookware black iron. It's not black iron until it's seasoned, and then it's ready to cook.
Then let's season these babies. Wait, season like salt and pepper?
What happens is we spray vegetable oil onto the cookware, and then it's baked on at very high temperature.
That's right, the baked oil creates carbon, which provides a natural non-stick coating. Just cooking with cast iron will build up more carbon, providing more non-stick coating.
The more you use this, the longer it'll last.
That's what I said. So let's get these pans labeled, boxed, and shipped out to homes everywhere, shall we?
Everyone should own cast iron cookware because it cooks better than anything else out there.
All right, I'm starting to come around on this. Cast iron really is amazing.
Oh, I knew I'd convince you. Okay, so quick, what's red and saves lives?
That's easy. My stress ball.
Or a fire extinguisher.
And to find out just how they save lives, we're going to Amerex's 400,000 square foot facility in Trussville, Alabama, where they make over 3 million fire extinguishers every year.
That's right, and this is Vic Modick, Vice President of Manufacturing. He's going to tell us why we all need our very own fire extinguisher.
It's good if you are an astronaut and you are in the movie Gravity and you need to move around the spaceship or travel from one station to another, you can use this fire extinguisher.
Right, yes, but there are a few more common uses, right, Vic? Like putting out fires?
Oh, it'll kill the fire.
Okay, good. But before it can do that, we've got to turn these simple steel cylinders into containers. A worker feeds them into a machine where a metal bottom and a threaded neck are added to the cylinder.
Next, a copper collar is added to both the neck of the bottle and the bottom.
And then the machine sends them off to Fernando, who works in the brazing department.
This is where all the fun begins.
Ooh, what happens now?
Next step is the oven.
The assembled containers are sent into a brazing oven for nearly 2 hours. The oven is set to over 1,000 degrees Celsius.
The heat in the oven melts the copper collars, fusing the neck and bottom to the steel cylinder.
And it looks really cool. After cooking, the cylinders travel a long way on a conveyor belt, cooling as they go, until they get to these friendly ladies. And who are you two?
I'm Glenda. I'm Vera. And we're the Embrace Flavor Girls.
Oh, nice jazz hands, ladies. You're looking good.
Oh, I guess we're pretty hot.
Glenda and Vera do a visual check of the cylinders and pack them into a box.
Next, the boxed cylinders are taken to the painting department.
Each cylinder is hand-loaded onto a hanger by Peter, and then it goes soaring off into the sky.
The suspended cylinders are first sprayed with primer, and then they go to Jason, who coordinates his shirt to his job.
I'm in charge of making sure the red paint is on the shells.
That reminds me, why are fire extinguishers red?
Everybody knows red means fire.
And romance. Nice shirt. Amerex uses red powdered paint to color their cylinders.
The cylinders are then sent into a 230 degrees Celsius oven that melts and cures the paint. It also gives them a beautiful shiny finish.
But beautiful shiny cylinders are no good without a firing mechanism.
Right.
To make the valve that controls the burst of firefighting power, 5-meter-long aluminum poles are fed into a machine that cuts and drills them into small pieces called blanks.
The blanks are run through a carousel which drills and shapes the blank into a valve.
Then the valve comes off the carousel, ready to use.
So, now that the cylinders have been put together, brazed, and painted, and the valves have been cut and shaped, it's time for the whole thing to come together.
First, the cylinders are filled with monoammonium phosphate, which is a dry chemical fire retardant. When it comes into contact with heat, it melts together into a solid, which coats and suffocates the fire.
Something that's been tested and is very safe for human use.
And it's also ideal for a household fire extinguisher because it can be used on both electrical and grease fires.
Next, the valve assembly is screwed onto the top by Christy.
Fire's got no place here.
Okay, why is she hitting that poor fire extinguisher with that hammer?
You hit it with a hammer to fluff the powder. Make it easier for the valve to spin. Double tap it so it's not loose.
Okay, well, as long as you have a good reason.
Next, the cylinders are pressurized. This machine fills the cylinders with 13 times the air pressure of a car tire.
Then the safety is hooked up so the extinguisher doesn't discharge before there's a fire.
Each assembled fire extinguisher is then subjected to a test by William here. He's a leak detective.
I guess you can call me a leak detective.
Good, because he wouldn't be able to stop us. William puts a set of extinguishers into these containers. The air is sucked out, creating a vacuum. If there's a leak in the extinguisher, the computer will detect it.
I mean, I guess that's kind of cool, but when you said that there was going to be tests, I kind of pictured, you know, like fire.
Oh, you mean like a dark room with a couple firefighters and a blowtorch?
Yes.
Well, ask and ye shall receive. Happy now?
Definitely. Now we know they'll fight fire.
Okay, good. So we can get back to the assembly line. Leak-checked extinguishers are labeled, fitted with a wall mount, and boxed.
And then they're shipped to homes around the nation.
No home is safe without one of these guys.
You know, I do feel safer knowing there's one of these babies handy.
Yeah, me too. Plus, I hear they're great for space travel. Ah, what a spectacular day.
Is there anything better than relaxing on a hammock?
Oh, yeah. Relaxing on a hammock with a cold glass of vodka and lemonade.
No drinking on the job. You have a hard enough time delivering your lines as it is, huh?
Point taken. We're heading down to Greenville, North Carolina to meet the good people at the Hatteras Hammock's 200,000 square foot facility.
And this man lounging comfortably on the job is Walter Perkins III. Tell us a little bit about the company.
My grandparents wanted a hammock, so my father bought two, learned how to make it, and started peddling hammocks out of the back of his car.
And how about you? Have you ever put a hammock together yourself?
I've done a bunch of them. I've taught it all over the world. China, India, Costa Rica, Brazil, taught it everywhere.
Alrighty then, so what do you say we give the Home Factory viewers a lesson?
Sure.
The first step is to make the rope which will be woven into the body of the hammock. Hatteras will use approximately 140,000 kilograms of rope in a single year. 3 strands are woven together to make a super strong triple-ply rope, and then it's wound onto a giant spindle.
Next, the rope has to be loaded for the weaving process. And here's the guy to do it.
Oh, come on, give us a smile. Ah, there it is, like a ray of sunshine poking out of the clouds.
And Mr. Sunshine runs a machine that winds the rope around large needles that will be used to weave the hammocks.
The completed needles are then delivered to the weaving workstations.
But before the weaving can take place, workers make a braid that forms the border of the hammock.
Wow, look at how fast her hands are moving. It's almost mesmerizing.
It is mesmerizing. For some reason, I want to do everything she says.
Snap out of it!
Oh, right. Yes, okay. And now it's the moment we've all been waiting for. A process that has remained the same for 100 years. It's time for the weaving of the hammock!
The weaving of the hammock is probably the most complex. It takes the longest period of time. It takes the longest time to train somebody to do it. And it's the most fun to watch.
Let's meet our weaver, Margarita. Hola, Margarita.
Margarita can weave 15 hammocks a day.
Yeah, and how much rope goes in each hammock?
We use about 1,000 feet in each of our hammocks, and that's about 3 football fields.
The football field, the unofficial unit of measurement in the United States.
Next, it's on to the hammock assembly. This is where all the different parts come together to make up the hammock, and Layla is definitely up for the job.
I'm pretty naughty.
Oh, I bet you are.
Nah, no.
She's referring to the hammock assembly process.
Oh, yeah, of course she is.
I put a hammock together.
But before she can start assembling the hammock, Layla needs something to hang all this beautifully woven rope on. She needs spreader bars.
So, let's meet the man who's all about the wood.
My name is Daniel, and I'm a supervisor in the wood shop here.
And this is not your average run-of-the-mill wood we're dealing with either.
No, it's not. This is a Brazilian kumaru. It resists weather very well and for a long amount of time.
The wood is sent through a gang drill to receive a set of holes that are an equal distance apart. Then the spreader bar is sanded to ensure the wood is smooth and splinter-free.
Okay, so back to Layla. And now she has her spreader bars. It's time to begin the hammock assembly.
This is the last step.
First, Layla puts a ring up. She ties a knot around the ring and braids it.
Then the rope ends are dipped in hot wax to prevent the rope from unraveling.
She lays the spreader bar on the ledge and feeds the rope through each individual hole. The sides of the hammock are then strung up and tied to the body. The completed hammocks are hung up. An inspector uses a hot knife to cut away any straight rope ends, and then checks each finished hammock to make sure the weave is perfect and the knots are tight and strong.
250 hammocks are made in a single day. That's $65,000 a year. That's a lot of relaxing.
So Walter, paint us a picture of how somebody should use your hammock.
A great vision of a hammock is somebody reading under a tree and relaxing and falling asleep with a book on their chest, and then maybe getting woken up in an hour later with somebody bringing them lemonade. That would be a perfect afternoon, I think.
Once approved, the hammock is rolled up, boxed up, and sent to home so relaxation time can begin.
Yeah, so can I have that vodka and lemonade now? Just pretend there's no kids here. Just pretend there's no kids.
A twist of the knife, a fork in the road, a spoonful of sugar.
You're just listing off utensil-based idioms.
Yes, and I could keep going. It just goes to show you how important flatware is to our daily lives. And that's why we're heading to Liberty's 243,000 square foot manufacturing facility in Sherrill, New York.
That's right. And we're here to meet the head honchos of Liberty Tabletop, Greg Owens and Matt Roberts. They're going to tell us why Sherrill is known as the Silver City.
This entire town was built by the factory, in essence.
This factory has been making flatware since the 1880s.
And all the forks, knives, and spoons start as 200-meter long coils of stainless steel.
The ability to take a raw coil of steel that looks like a clock spring and turn it into a piece of jewelry it's craftsmanship, it really is.
To make the knives, the steel is cut into 2-inch wide shapes, which are called blanks.
The blanks are then pressed into shape. 2 of these pieces are joined to create the handle.
But a handle is only half of the knife. The other half of the blade must be forged. That's flatware talk for making the blade.
Forging is a heat treatment that strengthens the blade so it doesn't break when people cut their food.
Meet Dave. He runs the hot forge area.
The temperature we're running is about 1,430 degrees.
That's over 750 degrees Celsius. Metal is placed in the furnace until it is red hot. Then Dave, in his 700-ton forging press, stamps it into the shape of a blade.
The blade is then trimmed in this 60-ton press.
And now we meet Kurt, a man who really is the sharpest knife in the drawer.
Kurt runs a grinding wheel that tapers the blade thinner at the front and scallops the front edges to create a serrated finish.
Let's put the teeth right onto the blade.
Sounds dangerous, and Kurt laughs in the face of danger. Ha ha! En garde!
Touché!
To attach the 2 pieces, liquid cement is spun into the handles using this carousel. Then workers quickly add the blade.
The knives then head through a washing tank, which hardens the cement and cleans off any excess.
With all this talk about knives, I feel like we're neglecting Matt's favorite utensil.
I'm a fork guy.
Okay, so moving on to the fork then, just for you, Matt.
This is another Dave. He runs the fork and spoon blanking press, which cuts the stainless steel rolls into paintbrush-shaped pieces.
So, Dave, how many of these bad boys can you churn out anyway?
This machine could make over 1,000 an hour.
Wow, that's a lot. To make the forks, the blanks are sent to a machine called a dial tiner. It cuts the tines into the fork. This is Annette. She runs the dial tiner and takes grooming tips from Little Mermaids. Looking good, Annette.
But the forks aren't. Why is there a bar on top?
Help keep our tines straight so we're ready to cut them off and bend them.
So it's not there to stop people from eating on the line?
No. I don't think you want to eat with these. They're covered in oil and...
Okay. A coining press puts a slight bend in the fork, which makes it easier to scoop up softer food. And then it's off to a machine called the nipper, which takes the bar off the end.
Ta-da!
Ooh, that's forktastic!
Good one. Meanwhile, on the spoon line, the paintbrush-shaped blanks are cut by a trim press. Then it's off to the coining press, which forms the bowl of the spoon and stamps a pattern onto the handle. When the utensils are finished, they're buffed until the steel is shining.
When running at full capacity, Liberty Tabletop can produce 40,000 pieces of flatware in a single day.
The finished flatware is dropped into bags and packaged as a set.
Stick a fork in me, I'm done.
And so are we, because this flatware is heading to homes and dining room tables around the world.
Just in time. I am starving.
Me too.
What's for dinner?